We've already learned about slope. That's one of our tools. Finding the length of a line segment. That's one of our tools. Today we're going to learn how to find the midpoint of a line segment. This is a different tool, our third tool for our tool belt. There's sort of one more and then other stuff you can do, obviously. But when given any 2 points A and B, I can use this equation to find the midpoint of that line segment. Another thing that's important about this unit is if you drew that triangle from the homework and saw that it was scalene and just said therefore scalene, well, I mean, you're right, like you can kind of look at it, but what we're learning in this unit is how to algebraically prove that things are true, okay? Not just looking at it and saying, oh, trust me, I've seen it, it's true. How do we present a proof, a mathematical, algebraic proof that something is true? That's what we're aiming for, okay? And so we do that with like formulas and by subbing in and doing algebra and doing computational math, right? So let's think about this case here. So it is 8, 5, 6, 7, 8, 6, and 2, 2. And I can draw a line between those. And if I think about, okay, so I'm going to start with the midpoint. So midpoint of, we'll say AB, is the x value of the first point plus the x value of the second point. Notice that that is different from both equations we were doing yesterday where we were subtracting. This is where it starts to get confusing. And then the x value of the first point plus the x value of the second point. Order doesn't matter. What am I doing when I add the x values together and divide by 2? If I add 8 and 6 and divide by 2, what do I get? 8 plus 6 is 14. Divided by 2 is 7. 7 is the middle of 8 and 6. I'm finding the middle of the x values. It's like taking an average. If you want to take an average of your test scores or whatever, you add them up and divide by how many you have, right? So I'm finding the average or the midpoint, because it's only 2 points, so the average of the two x values. And then same for the y values. I'm adding them up, dividing by 2. And so I'm finding the average of the y values. And those are just my x and y values of my new point. Okay, so that equals 7, and then 6 plus 2. Sorry, where did I get 14 from? I was thinking 8 plus 6. 8 plus 2 is 10, divided by 2 is 5. 6 plus 2 is 8, divided by 2 is 4. If you did not use brackets properly, if you did this on your calculator, which you should be able to do that in your head, but if you did this on your calculator, and you did, see that okay? Nope. 8 plus 2 divided by 2, you would get the wrong answer. Why? Because that's not bed mass, right? That's 8 plus bracket 2 divided by 2. It's got to be 8 plus 2 first, and then divide by 2. Do it in your head, or make sure you do it properly on your calculator. 5, 4, so I go over 5, up 4, and there's the midpoint. And it does look like the midpoint. Sometimes you can kind of, again, from the graph, you can kind of see where the midpoint is, but we want to calculate it. Okay? Pretty straightforward. Something to think about, though. The slope formula, you start with your y's on top. You got your x's on the bottom, and you're subtracting. The length formula, it doesn't really matter if you start with your x or your y's, but as a standard, we have x's first. We subtract and then square it. And then we add the y values that are subtracted and squared. So we're sort of subtracting in the brackets, but adding between the brackets. And then this one, we're adding and dividing by 2. And we're writing it as a point. That's a bit of a different kind of formula. It's written as a point. So all three have their similarities, but they're different in an important way. And this is where it does get tricky, where people start to get them mixed up. And you thought you were really good with the slope formula, or you think this looks really easy, but you start subtracting the y values because you subtracted the other ones and that sort of thing. So that's why I said yesterday, like, you do have to really practice this so that you nail the formulas before they get muddled up in your head. Okay, so try that first one. Careful of your form. Make sure you got brackets around it. It's a point. So you need brackets.
When we divide by 2 equals 3, would it be negative 3? That doesn't seem like the midpoint between the both lines.
So what
So
negative 6 and 5 and 8 and negative 11. Negative 3 for the midpoint, right here. Negative 3y.
but wouldn't that be a good thing? But like division negative and positive.
You divided.
Oh, no.
You're right. How many people got 1 comma negative 3? Look at your answer and see if you've got brackets around. I forgot to write the formula. Ooh, bad. There wasn't a lot of space, I know. So make sure you have brackets around the whole thing. It's a point. This is actually, again, quite important. Like, this is how we write points compared to how we write equations in mathematics. So make sure you got brackets around every position. 5 plus negative 11 is like 5 minus 11. If you can write just 5 minus 11, that's fine. Just make sure you're doing it properly. Okay, try the next one. got negative 2.75 and 1.1? You good? Questions given to you in decimals, it's usually safe that you answer it in decimals. It's given in fractions, you probably should be answering in fractions, even if the fractions work out nicely. We're going to talk about that. Okay, we're going to do more of this kind of stuff in the next unit, but we might do a couple here or there, sort of simpler ones like this. Verify, show, or show. Verify means, this is important. I'll say this again when it comes up, but so listen carefully. Everybody listen. Verify or show is telling you that it's true. So the question is saying what we're about to check is something that is true. Okay? It's telling you that. If it says determine whether the diagonals bisect each other, that's not implying that it's true. You have to check and see. But if it says verify or show, it's true. So don't say no, they don't. Yes, they do. The question told you. It means you made a mistake. Okay? So just be aware of that. Like that's a little hint if you're ever doing a question like this on a quiz or a test that it's true. You got to make sure you get the right answer. So what does this mean? This is where a nice sketch, just like simple, not to scale. I should have a grid here, but I don't. But that'll be okay for this question. Just doing a sketch will allow me to visualize this. So you should always do a sketch for a question like this. For just a midpoint question, you don't need to sketch it. If you ever have a learning goal, a quiz, or a test, and you're given a grid, you should be sketching it. Even if you're not given a grid for a question like this, in your homework or on a quiz or whatever, probably a sketch is still a really good idea. Okay, so here's how we're going to sketch it. I'm just going to go like this, and I'm just going to ballpark where these are. So A is 1, 3, and I'm going to label them. B is 4, 1. C is 1, negative 1. And D is negative 2, 1. So now I know the question should give you the points in order, but there's no guarantee that it does. What if the points aren't alphabetical? They don't make a rectangle alphabetically. But now I know what this looks like. And here's the trick. What are the diagonals of that shape? This is something else that probably a lot of you would guess, but you've probably never seen before, so you wouldn't know for sure. Ben, what do you think?
AC.
Exactly. So AC is one of the diagonals, and DB is the other. How do I show? What does the word bisect mean? What do you think, Andy?
Is that where they cross?
It has to do with where they cross, but it's even more than that.
Isn't it like where two angles cross that makes a 90 degree?
Not necessarily, although that is something that will come up later.
Like 3 divided 2?
They cut each other in half. What does dissect mean? It means like you cut open like a cadaver or something, right? Like you dissect a mouse or a frog or something. So dissect means you're cutting open. Bisect, bi means two, it means cut in half. So you're cutting exactly in half. Okay, so that make sure you know that. Bisect means cut in half. And so bisect each other means they both cut each other in half. How am I going to show that? It means the length from D to the middle is the same as the length from B to the middle. And the length from A to the middle is the same as the length from C to the middle. My little sketch here actually doesn't look like it cuts D and DB in half, but remember, it's not a perfect graph. It's just a sketch. I can't tell for sure looking at a graph if this is true or not. So when I look at that, I don't know. So we're going to calculate it. So how could I figure out if they bisect each other? I mean, think about what we just did.
On each one, so you do D and D as your x's and
And okay, so find the midpoint of those two line segments, the diagonals, and what would you find if they do bisect each other? What would you find about the midpoints? They would be the same, right? They would have to be the same. Whatever the midpoints are, they'd have to be the same. They have the same midpoint, they bisect each other. Does that make sense? Okay, let's try it. If it doesn't make sense, we're going to try it and then think about it after. So this is like a little mini essay. We're doing a proof here, or a verification. So we start with our introductory paragraph, x1 plus x2. So this is what I'm going to do. I'm going to find some midpoints to prove this. So now I'm going to find the midpoint. My diagram told me that I want to find the midpoint of AC. So 1 plus 1 over 2, and 3 plus negative 1 or minus 1 over 2. 1 plus 1 over 2 is 2 over 2, which is 1. 3 minus 1 over 2 is 2 over 2, which is also 1. Plus negative 1. So minus 1, yeah. The formula is absolutely plus, but we added a negative 1, so I just did my A. This is a nice thing about a sketch. Does that answer make sense? Look at my sketch. Could you believe that that point there, A, C, might be about 1, 1? Yeah. Like if I got an answer negative 10, negative 14, ooh, wait, that's not even close to being inside that shape, right? So it also allows you, and that's something that you should do. Again, if you give answers that make no sense for the question or for your diagram, you should be catching that. And that's like just a problem-solving technique, right? That helps you catch your mistakes. So it's something you should be practicing thinking about. Okay, try the next one on your own. Okay, awesome. Lots of people got it. So, I also came up with my little summary statement. That's an upside down therefore statement. I think a lot of you already know that means since. So this is the kind of summary statement when we do more proofs, which is more in the second part, like the next unit. We'll talk more in detail about this, but it's good to start thinking about it now because it is a little bit tricky. Since the midpoints are equal, the diagonals of A, B, C, D bisect each other. So we need to start learning how to refer to things, how to refer to a quadrilateral A, B, C, D. We don't just write what is true, we also write why. That's a big part of these summary statements. And when I'm looking for both those things, if you don't give me one, you can say that something's true, but I need to know that you know why it's true. Otherwise, people just write a whole bunch of stuff down and say, therefore true. Like, okay, but why? Like, what in your work says that this is true? Okay, so keep that in mind. So that's the kind of statement that you want to have. When this is another thing, like, I've mentioned this before, and maybe people roll their eyes, why is that such a big deal? And your grade 9 teacher might have done this too. Slope is a little m. Wait, slope is a little m And there's a reason why you can't change that. You're not allowed to use a capital M for slope. Because we're using capital M for midpoint means something different. Right? So if you interchange them, then it's harder to follow exactly what it is you're talking about. Okay, one more question. So this is like something that you want to kind of have a moment where you go, oh yeah, that question's different. Because we're doing one right now. There's one in the practice. But even though we do one in class and then people do it in the practice, they go, I don't know how to do that. Well, remember the one that we did in the lesson? That was different. So here's your model, and it is tricky, but think about it and work with it because it will come up on a quiz or a test. Okay. But once you've done it a few times, again, it's very repetitive. It's kind of the same thing all over again. But it shows us the kinds of things that you can do in math. So the midpoint, let's draw it because I don't understand what it's saying. JK is a line segment. Point J is -7, 1. The midpoint of JK is -3, 2. Find point K. So it gives me the midpoint, and it gives me one of the endpoints, and I have to find the other endpoint. So it's similar, but then a little bit turned around and backwards. Kind of, but because it's on a diagonal, that won't. You'll have to. You could, yeah, that would work, yeah. And if you want to think about it that way, to make sure that your answer is correct, that would work. But let's take a look at an algebraic approach. So here's what you do, and here's a good problem-solving technique. Again, I'll talk about this again, but if you're not sure, if you get stumped on a question like this and you're not sure what to do, I mean, it's midpoint, so let's write down the midpoint formula and sub in what we know and take a look at what we have. So we're going to start with that. Midpoint is x1 plus x2. Like, I don't know how to solve this. So I'm going to just, well, I'm guessing it has something to do with the midpoint, so I'm going to just start with this. Now, it gives me one of them. So the midpoint, wait, I'm not going to do that. So it gives me one of them, and the x value is -7 plus x2 over 2, and the y value is 1 plus y2 over 2, and it gives me what it should equal. Does that make sense? So what can I do with this now that I'm looking at it? Can anybody tell me anything about what's happening there? Remember, it gave me the midpoint, so I subbed that in over here on the midpoint side. And it only gave me one of the values for inside that equation. So then I just used x and y, x2 and y2, or x and y for the rest of it. Parker?
You sub in the x on the left or the x in the equation.
This x is not the same as this x. Those aren't the same, so I can't sub one of those in, but that's a good idea. Natalie, you had your hand up. What were you going to say? Kind of the same thing? So this whole thing has to equal that. Is that true? Okay, so therefore, -7 plus x2 over 2 equals -3. What else do I know? I know that this thing has to equal that. So, and 1 plus y2 over 2 has to equal 2. Well, now I have two really simple linear equations, and I just solved them. So I'm going to multiply both sides by 2 to get rid of this, right? Gone, gone. So I get negative 7 plus x2 equals negative 6. I'm going to add 7 to both sides. And so x2 equals 1. Try the next one yourself. So I got, whoops, I should write that down. Therefore, point K is 1, 3. But does that make sense? Does that make sense for that? Well, that's in the top right quadrant, 2 positives. That point looks high, but that's just how I sketched it. So yeah, that makes sense. Right? The y's changed from 1 to 2 until up to 3. And from negative 7 to negative 3, just over 1. So it does make sense. Like, sure. If it was way down here somewhere, then I would be like, ooh, guys, you was thinking this. Yeah, I'm missing stuff over there. If it was way down here, that wouldn't make sense. But it matches my sketch at least a little bit, so that's good. Okay, what do you think? Any questions? That's just a special kind of question. There's one to practice. It comes up once in a while.